you need to at least write you need to at least write at least one sentence or two sentences. What you know, I mean, it has to be, if the answer is 100% true, you should write some 120% to get the 100% marks. That is how the chemistry is treated in the board actually. So you got to be little more. So for that way, I will be little tougher on this actually, and I will give you the little more tougher question only as we go further and further, so that you get prepared very well actually. That is that.
Okay, sir.
Okay, otherwise maybe you might have lost only 1 mark here and there, and totally another 1 or 2 marks extra you would have done that. But overall, the range is going to be there only. So by adding another 1 or 2 marks, it is not going to be a great good marks or anything like that, because you have lost marks in many other places also. That also you have to think. So this is one of the thing. You are right actually. I also agree that that is answer to the point. When you do answer to the point, they normally give just little lesser marks. They say that handwriting is not good, presentation has not, so many things they will give that. It depends upon the evaluator. If your evaluator is very loose evaluator, you get the full marks. If he is a very strict evaluator, you get little less mark. So plus or minus 10% depends upon the evaluator only. For that reason, you have to pray God only, so that you get a good evaluator. So that's the only thing. So now let us go to the chemistry. So where is the chemistry? You want to check your papers? Should we open? Not necessary, right? Or individually, if you want to check, or we
No,
need to
sir.
check it.
Only that part I had out.
Oh,
Other than that, everything I have done mistakes, so I'm fine with
okay,
it.
okay. Right then. Please correct those mistakes and other things, and next time you try to be little more careful. Okay, class 10 chemistry. We are going ahead with Selena. So today let us try to at least do good part of the Selena. Okay. Let me here in text questions. Okay. Last time we said that atomic sizes will reduce. It will reduce up to group 17, and after that in the group 18 it will increase again. And there is a this one also, why this exception is there here. It is been given as an expression. Size of the atoms in the inner gas are bigger than the halogens actually. So this is the halogen family, there is a fluorine. So neon is bigger than the fluorine. Why it is bigger than the fluorine? He says here it is bigger than the fluorine for two reasons. Because they have maximum number of electrons in their outermost orbit, thus the electron repulsion is maximum. Can you read this? This is maximum number of electrons. That is almost all octet rule, 8 electrons in their orbit. So the electronic repulsion is maximum here. The effect of a nuclear pull over the valence electron is not seen here. So it won't pull much actually. It is not seen here. Hence the size of the atom of inert gas is bigger. Okay, this one, but not bigger than the alkali. The first atom is there, no? It is not bigger than the first lithium. It is not bigger than the helium, but it is as bigger or a little bigger than the beryllium. You can see it's almost all equivalent to beryllium here. In this case, in some cases, it is maybe little bigger also sometimes. So it is almost all equivalent to that. So while these things are going on, you can see the value here. It is 152 picometer. It is 112, 88. It is all reducing. You can see it's all reducing. It is nothing but a radius of this atom. So 66, 64 is the radius. Here suddenly the radius has become 112. This you have to keep it in mind. So we also read about last time only we saw cation and anion, which is going to be bigger in this. So it is going to be always, so atom is going to be bigger than the cation. Why? So cation is going to be smaller. So that's also uh, because the number of electrons are more in the cation. So that's why. So if the electrons are more, the nuclear pull on them is also more. So it is going to be like that actually. So sodium ion is going to be smaller because the pull is higher. Similarly here, anion is larger because it has lost an electron. So sorry, it has gained anion is formed by gaining an electron. I'm sorry for that. Gaining an electron. So once it has gained, so its pull again is much not mucher. So anion is larger than the parent atom. So that's going to be. Now metallic character. What is a metallic character? It's ability to give the donate the electrons, or ability to lose electrons is known as a metallic character. They don't mind losing that. So they are metallic characters. So all those in the group in the periodic table, if you see, all those on the left hand side have got a metallic character. So thereby, if you go to the periodic table, I have not shared it, I think. Yeah, this is the periodic table. Have I shared my screen? So hope you are able to see my screen, right? So in this, if you see it, so it is going to be the metallic character is going to be very high
Yes, sir.
on the left hand side, on the left hand side. Whereas on the right hand side, metallic character is almost all zero. So metallic character always goes from here to here. If I draw a line, it always goes from here to here. The metallic character is higher. Similarly, it is higher as you go down also, but we only show one. It is going like this, it is going higher. So this is the metallic character what we saw that. Okay, all right. So next let us do. Similarly, non-metallic character. Non-metallic character is opposite actually. So non-metallic character will be much higher on the right hand side. Why? Its ability to gain electrons is non-metallic character. That also we have seen. So here also it says that the down the group metallic character will increase. Thus metallic nature increases down the group. Similarly, as you go across, the metallic character will decrease from left to right. Okay, non-metallic characters other way. Down the group it will increase, and sorry, down the group it will decrease, and if you go from left to right, it will increase. So that is the non-metallic character. That's also we saw that. So to be frank with you, say for example, if this is where is my pen, here it's going to be. If you are periodic table is like this, let us consider here two things. So metallic character, what will happen? Metallic character will increase like this. It will increase. So that means down the group it will decrease, down it will increase. This is metallic character I am telling, MC. So down the group it will increase, and across is always left to right. Across, that is left to right also, it will decrease here. As you go from here to here this way, it will decrease. Okay, right to left it will increase, left to right it will decrease. Now let us come to the non-metallic character. If you come to the non-metallic character, what is a non-metallic character? Its ability to gain electrons. Here it was a lose electron, here it is gain electrons. And you
It is
know,
gaining.
actually these guys know which are there, the metals, sodium, medium, and all other things, whatever was here, sodium, potassium, all these things, lithium, sodium, potassium, all these, they don't gain electrons, they lose electrons. So non-metallic character is almost all zero here. It's almost all zero. So as you go up, as you go here like this, it will increase. Non-metallic character will increase across. So here also, as you are going down, non-metallic character, as you go from top to bottom, non-metallic character will decrease. So say for example, here you have got fluorine on the top. So down below fluorine, you have got a chlorine, and then iodine, then you have got bromine, all this. So as you go down, the non-metallic character will decrease. Fluorine has got a high non-metallic character. That means it wants to immediately gain an electron. Its love for the electrons is very high. It is hunger for electrons is very high. Chlorine is little less, iodine is much more less, bromine is much more lesser. So like that, downwards it will decrease. And similarly across, that is left to right, if you go, metallic character will increase. Across, left to right, it will increase. Non-metallic character will increase. Its hunger for electrons will increase. Okay, this is what all about it. So chemical reactivity, we saw that. So now we are going to go ahead with, okay, there is one more trend which we saw, non-metallic character we saw. Now let us see what is a chemical reactivity. So the reactivity of elements depends upon their tendency to lose or gain electrons. So the greater the tendency to lose or gain electron, greater is the reactivity in case of metals. So in case of non-metals, it is the losing electron. So you see across the period, if you see gaining or losing, the metallic activity or the chemical reactivity, you will see it is very high in the first group and 17 group, because first group always wants to lose electrons very fast, and the 17th group always wants to gain electron very fast. Thereby their metallic activity is very high. So metallic activity will decrease as you go from first, second, third group wise, if you go on. And again it will decrease this way. Say for example, I will go and show you in the this one. Say for example, I'll go to this. Here we should have done this little better. Okay. Now if you see metal chemical reactivity, we are talking about chemical reactivity, that is CR. Chemical reactivity is very high in the first group. Why it is very high in the first group? Because this first group fellows wants to lose electron immediately. There is only one electron. They want to lose that electron and gain a stability. So their ability to lose first electron is very high. Thereby chemical reactivity of the first group is higher than the second group. Say for example, if you consider sodium and magnesium, which are in the both are in the period 3. In the period 3, if you see, sodium has a higher reactivity than the magnesium. Similarly, if you see potash and the calcium, potash has got a higher reactivity than the calcium. Say for example, sodium and potassium, if you put it in water, they will immediately go on fire. They will so violently react, they will go on fire. Whereas magnesium and calcium will not violently react. They will also react, but a little lesser. Similarly, if you take to the third group, that is bromine, aluminum, galvan, they also react, but much lesser than this. Like that, if you keep on going, it will be reduced. But one thing you should remember, so from group 1, reactivity is higher, so reactive will decrease. So 1 is greater than 2. That means here it is group 1 reactivity is higher than 2, and group 2 is higher than group 13. Let us take the 13. So it is higher than the 13. But fourth one is a stable. Fourth one, either it can give or it can not give. So its reactivity is almost all zero, we can say. But when you come to the 17th group has got high reactivity, and then it will decrease. That is the oxygen, all these things are lesser reactivity, and this one is much lesser reactivity. Got it? So what will happen is reactivity is in the textbook only I will show. Reactivity will, say for example, you have got group 1, 2, and then you have got 13, 14, 15, 16, and 17. Let us take this much. So here, of course, 18th doesn't have any reaction at all. So I am not telling. Their reactivity is 0. So 18th reactivity is 0. So whereas here, group 1, say for example, we had sodium here. Sodium has got a higher reactivity than, next one was what? Magnesium. Higher reactivity than the magnesium. Okay. Similarly, it has got a higher reactivity than the bromine, I think here it was. Okay. Similarly, here it is a carbon. So these two are reactivity will decrease like this here. And here almost all minimum. Here reactivity is minimum. So then again it will increase from here onwards. Reactivity will increase. So here it is lesser than this, lesser than this. Here if you see, here it is going to be nitrogen, oxygen, and fluorine. So fluorine reactivity is much higher. This is higher. So nitrogen is lesser than oxygen, and oxygen reactivity is lesser than fluorine. This is how it is. Here also it is going to be like this. So this is the way reactivity goes. Chemical reactivity. Please remember this. Hope you are clear about the chemical reactivity, right? So here you can
Yes.
see that the chemical reactivity, he also explains same way, sodium, magnesium. So chemical reactivity decreases, and Si, that is the least. The Si is just below the carbon. It has got the least reactivity. Again, phosphorus, sulfur, chlorine, the reactivity will increase from here to here or decrease from left to right. That way, the tendency. So here also the tendency of losing electrons or gain the electrons. Its ability to lose or gain the electrons immediately. Its ability to participate in the chemical reaction immediately. That's what is most important here. Okay. All right. That is what we saw it here. So this chemical reactivity, you see the melting and the boiling points of the metals also decrease as you go down. Say for example, as you go down, because the chemical reactivity is less, so its ability to lose the lose the electrons is much faster, so the is lesser, so the its melting point will decrease. So melting point here is much higher. Say for example, melting point of lithium is 180. As you go down, the melting point will increase. Melting point will increase. Similarly, the melting and boiling point of the non-metals, it will also increase as you go down. As you go down, fluorine, fluorine, bromine, it will increase. So melting point or the boiling point, what they will do is they will decrease as you go down the this one. Why they will decrease? Because it's a tendency to gain electrons decreases of the group. So hydrogen wants to react immediately, but if you go to lithium, it is less reactivity. Sodium is much more lesser. Potassium is much more lesser as you are going down, So therefore, as the reaction comes down, so its ability to lose the electron also comes down. So its ability, its melting point and other things also will come. That is what it is. Okay. So that is the thing. Across the period left to right, melting point and boiling point usually increase up to group 14. So it will increase up to group 14 and again it will decrease. Say it is also like here. So from here to here it will increase. That is sodium as a lower melting point, magnesium, aluminum and silicon. So it will keep on increasing like this up to silicon. From silicon onwards again it will keep on decreasing up to chlorine. So chlorine is the least melting point, and sodium also has got a least. Actually sodium that way will melt also immediately. So those are the ones. So density of elements across the period decreases gradually. That also we saw. Okay. Now let us quickly go through the question answers.
So, is there a shortcut to remember this, like how it goes up and down?
Yeah, there is a shortcut. I will try to see and try to share it with you. Okay, on all the characters, including the melting points and all other things, I will try to share it. Okay, or otherwise I will prepare one chart and then try to share you, so that in all the charts, in everything, you will be able to remember melting point and all other things, how it will decrease. But only thing is that read the textbook and try to get the concept by yourselves. Once the concept comes in your mind, then you will never be able to forget. Then how to remember that table or the chart will help you further. Okay, but concepts you should get. Chart alone will not help you. Okay, please go through these question answers. In case you don't know any of the question answer, please let me know. Let us go and answer this. Are you able to see the question answers here, right?
Yes, sir.
Or should I make it little bigger? Okay, 1 2 3 4 5 5 questions. You see, I'll just lock the door and okay, let's go. What do you understand by the atomic size? Atomic size is nothing but the size of an atom, right? Or,
Yes, sir.
or you should say that,
And
and it can be, it is referred as the atomic radius also, and
yeah,
it is the distance from the center of the nucleus to the extreme nucleus. Okay,
sir. And unit is like in Armstrong. It is like it
Armstrong's
is
only. It
one
can be,
Armstrong or picometer, right?
yeah, it can be either Armstrongs or picometer. So you know Armstrong. Armstrong is nothing but 10 to the power of minus 10 meters. Okay, and picometer is nothing but 10 to the power of minus 12 meters. Correct. So this is what it is. Now let us go to the give the trends. So this is the its unit is in both. Okay, it can be in Armstrongs or otherwise picometers. Very good. Now let us go to the next one. So down the group, give the trends in atomic size. So down the group, what will happen? As you go down, number of orbits will increase. So down the group, it will
So
increase only.
down the group, the size of the atom will increase.
Yes, down the group size of the atom will increase. And here when you say size of the atom will increase is the right answer, but try to give a reasoning for that because you know that, right? So in case if it has got it carries a good amount of marks, you should cite. So down the group size of the atom will increase because the number of shells will increase down the group. Each shell will increase, no, successively one shell will increase in each period. So thereby number of shells will increase, number of orbits will increase, so therefore atomic size will increase. Very good. Across the period left to right, what will happen? Across the period from group 1 to group 17 it will keep increasing. Okay, it was a test question also, so you have all written. So only thing is that I have corrected it wherever it is required. Okay, across the period again it decreases from 1 to 17 because the nuclear charges, I mean the number of protons is high, so the nuclear pull is higher. That's why. But it is not, and only exception is group 18, and group 18 doesn't. Group 18 is full of
So we
octets.
have to write the exception part.
Not necessary. You can write across the period
Actually, in
up to
my
1 to
paper, so
7.
you have marked that exception part.
Yeah, only up to the exception part. If you can put it, that is superior. But why the exception? You need not have to write. You have to just write that nuclear pull is more, so thereby this one nuclear the atomic size is lesser. So that's it. Across the period, it is left to right. It decreases. That's right. Okay. Next, arrange the elements second and third period in increasing order of their atomic size, excluding noble gases. Okay, arrange the elements of the second period and third period. Here you see, you need to know what are the second period and third period atoms. Can you tell me what are the second period and third period? Second period, now the increasing order. That means the smallest one you should take and exclude the noble gases. Okay, which is the smallest across the period in the second period? So smallest is fluorine. I'm telling period 2. So you remember the mini periodic table, right?
Yes, sir.
Yeah. Let us draw the mini periodic table quickly. Mini periodic table is going to be something like this. Where now it will have one more here. It will have one more here. Now this is nothing but 1, 2, 13, 14, 15, 16, 17, and 18, right? So 13 and 14 I can write here also. This is this much. This is consisting of 18 elements. Then you add another 2 so that it will come for 20 elements. That's it. This is going to be your periodic table. Now
Yes.
quickly tell me what are the ones. Next, helium, right? 1, 2. So third one is going to be, can anyone tell me?
So third one,
Lithium,
lithium, beryllium,
beryllium, very good. Next,
boron.
boron, very good.
So what is it? Like 13 2 we have named in the same.
1 to 13, 14. Oh, here it is a little one thing is more, so I need to cancel this one.
No, sir, it is correct. Like, see, 1, 2 everyone. 13, 14, you marked it wrong. First two columns, then.
Ah, okay, okay, okay. One more. 2 is here. So this is 2 and this is 13 and this is 14. You are right. I'm sorry for that. Okay. Right. Let's go to and carbon. After the carbon, you will get nitrogen, oxygen, and then fluorine. Then you have got neon, right? And the next, what is that? Third one, sodium, then magnesium, then Silicon.
Sir, silicon.
Yeah. Oh, sorry, not silicon. It is aluminium. Aluminium, silicon, here phosphorus, here sulfur, here chlorine, here argon. Then
Argon, then potassium, then calcium.
potassium and calcium, Ca. Yeah, this is the one. Now, whenever he asks that, he says that ascending order, not ascending or descending order. What he has asked? Arrange the elements in the second and third period in the increasing order. Increasing means, so it is ascending only. That is nothing but you have to keep the smallest one first. Increasing order means smallest one first. So in the period 2, let us take it. In the period 2, the smallest one among 1 to 17 is, you should not take this. So 1 to 17, if you take it, fluorine you take. Then next is oxygen is bigger than this. Next you have got nitrogen, and more bigger than nitrogen is carbon, and then the boron, then beryllium, then lithium. So this is the ascending order of atomic sizes. Ascending order of elements in terms of atomic size. Atomic size or atomic radius, whatever you want to call it. Okay, this is the one. This is for the period 2. Similarly, for period 1, sorry, for period 3, the ascending order of elements in terms of their atomic size is similar to that. Actually, you should start with chlorine. Chlorine is the smallest. The next one is going to be sulfur. Next one is going to be phosphorus, silicon, aluminium,
Aluminium.
magnesium, and sodium. Sodium is the biggest in this. Chlorine is the smallest. Are you getting my point? Hope you have understood. Please make a notes of all these
Yes, sir.
answers once the class is over. And in case you are not getting any of the answers, please connect with me so that I will tell you what is the answer for that. Okay. Right. Now let us go to the, why is the size of neon greater than fluorine and sodium is greater than magnesium? He is asking. Okay, find where is neon. Neon is here. He says that why is this fellow neon is greater than fluorine? So you know the exception. So why it is greater? Because neon has got more number of octet rule. I mean, it has got more number of electrons in the orbit shell, and it is quite satisfied with it, and thereby the electronic repulsion is higher in neon. Thereby the nuclear pull is, I mean, you know that there was a box in your book, you can refer that. So there he has given why is this more. Yeah, here we highlighted this in this. So why this exception? Similarly, you have to say that neon is greater because the maximum number of electrons in the outermost shell, there is electronic repulsion is maximum. Okay, therefore the effect of the nuclear pull on the electrons is minimal. Okay, it is minimal or it is not seen. Thereby the atom of neon is greater than the atom of fluorine. So atom of neon is, size of the atom of the neon is greater than the atom of the fluorine. Okay, it also refers to even the argon to chlorine also, same thing. Got it? So please do this little faster. Okay, right, now let us go to the next one. Okay, what we were there. So third one now. Okay, why is the size of, okay, in the same thing he says that sodium is greater than magnesium. Oh, definitely, because after the sodium only, because sodium is in group 1. So in the group 1, sodium is greater than the magnesium because sodium has got more number of, why is sodium greater? Okay, sodium has got a less number of protons compared to magnesium. Thereby, sodium has got a lesser nuclear pull than the magnesium. Thereby, the sodium is greater than the magnesium. Correct? Because sodium and magnesium come in the same orbits only. Sodium and magnesium. But if you see sodium, sodium is bigger than the magnesium because the number of protons in the sodium is lesser compared to number of protons in the magnesium. So sodium nuclear pull of the sodium is higher, thereby the size is lower. If the nuclear pull is higher, it shrinks more, right? So thereby the magnesium is lower than the sodium, so this is smaller. So if magnesium is, if sodium is this much, magnesium is only this much. So if this is sodium, this is magnesium. Why magnesium is lesser? Because magnesium is lesser because nuclear pull is, or nuclear attraction is high here. Nuclear pull is high. Since nuclear pull is high, so its size is low. Okay, because it is shrinking, it is attracting all the electrons towards the nucleus center, whereas here the nuclear pull is less, so its attraction to for the electrons is lesser, so thereby it is not pulling the electrons so heavily, so thereby its size is higher. Okay, now let's come to the next one. Why is the size this we arranged it? Okay, which is greater in size, an atom or cation? You have already answered that, right? So it is always an atom is greater than the cation. Similarly, atom or anion is greater. Similarly, some people have not answered this, Fe2 plus and Fe2 plus 3, which is greater? Fe2 plus is greater because it has got higher number of, lower number of electrons compared to this. Here the number of electrons are more compared to the same protons actually. So thereby the nuclear pull here is much higher than this. So Fe2 is greater. Okay, please go through and read. I have answered this also in your this one book. So please read that in your answer sheets. Which has higher EA, fluorine or neon? What is EA? What is EA? Electron affinity. You remember what is an electron affinity? Affinity is love actually, so it's love for the electrons, so its ability to get the electrons. So which is higher? So fluorine or neon? Definitely fluorine has got a electron affinity more higher, because fluorine wants to gain one electron, whereas neon doesn't want to gain any electron, so fluorine affinity is very high. Got it? So if you are not clear, please ask me. Which has a maximum metallic character? Sodium, lithium and
Yes,
potassium.
sir, clear.
Yeah. Which has the maximum metallic character? Sodium, lithium, and potassium. Let us go back to our small periodic table. So this one. So which is having sodium, magnesium, and what is that? Lithium. It says sodium, magnesium, lithium. All these three. In these three, which is having a more higher? This one. He says that this one, and this one, which is having a higher. What he says? Where is this? Which has the maximum metallic character? Metallic character, which is the maximum metallic character? Here the maximum metallic character is in the sodium. Sodium is having a maximum, so maximum is equal to sodium. Maximum metallic character is sodium here, this one. Why? Because as you go down the line, the metallic character will decrease, that we have heard that metallic character is higher, its ability to lose electrons is much higher. As you go down, it decreases, so metallic character is greater here. As you go down, it is greater. So sodium is maximum compared to lithium, and sodium is maximum compared to magnesium. We know metallic character is always like this actually, so this way. So here also in this whole group, potassium metallic character is higher comparatively, so that's why this is the one. So here among these three, sodium is highest. Sodium is highest. Then next comes lithium. Why between the lithium and magnesium, why lithium is highest? Because lithium has got a foremost, this has got only one. It can lose the one electron easily compared to magnesium. So next is lithium, next is magnesium. So if you want to compare this, it is first is sodium metallic character wise. It is sodium, then sodium metallic character is greater than, it is greater than, sodium metallic character is greater than lithium, and lithium metallic character is greater than magnesium. This is how you have to keep it. This is the order in which you have to keep it. Very good. Let us see other one. Sixth one. Arrange beryllium, lithium, carbon, boron on an increasing metallic character. Here also same way. If you can see, whichever is the downmost, downward, left down, okay, left down corner, that is the highest. Among this, which is the left down corner, you have to first find out. Beryllium, lithium are on the left side, but which is the downward, that you have to see, that is having the most increasing metallic character. Increasing means first you start with the lowest. So lowest is definitely the fluorine on the top is the lowest. This is the fluorine is the lowest. After the fluorine, you get oxygen, then nitrogen, then boron, no, then carbon, then boron, then lithium, then beryllium, then lithium. So shall I write it here? Because the metallic character will decrease as you go this way. So it is going to be, the lowest is fluorine, after that fluorine, after that then next is oxygen, because after the fluorine just beside that oxygen is there, after that it is nitrogen, and after the nitrogen then immediately you have got a carbon, after the carbon you have got a boron, and after the boron, I mean left to right if you are coming, after the boron, after the boron you have got beryllium and then lithium. So this is the way you have to write it. Got it? Similarly here also. Here also you are going to be, chlorine is going to be the lowest. So it is going to be chlorine. So once after the chlorine has got the lowest metallic character in decreasing non-metallic character. Okay, arrange the decreasing non-metallic character. Okay, non-metallic character should be decreasing. That means metallic character should be increasing. That means lowest metallic character first you have to write. Okay, chlorine has got the lowest metallic character or the highest non-metallic character. Okay, other both ways you can read it. Then after the chlorine comes sulfur, and after the sulfur you have got phosphorus. You can see it here also. That mini periodic table you have put it. So the chlorine, then the sulfur, then phosphorus, then silicon, aluminum, magnesium. You can see that. Then you have got a silicon, aluminium, magnesium, then sodium. Right? This is how it is. Any doubts, please ask me. Otherwise, I am going to go for seventh one. State the trend in chemical reactivity. What is it? When they say trend means across the table, whether it is increasing or decreasing, and just give a small reason why it is decreasing and decreasing. Across the third period, okay, across the third period from left to right. Across the third period from left to right. Third period starts with the sodium actually. So it is sodium, magnesium, other one here, this one across that. And state the trend in chemical reactivity. You know, in the chemical reactivity, sodium has got the highest chemical reactivity. Then next lowest is magnesium and next lowest is aluminium. That's how it is decreasing. Chemical reactivity is decreasing that way. So let us see how we are. On moving left to right, chemical reactivity of the element first decreases and then it increases. So it first decreases and then increases. This is the trend here. It is first, the here we are talking about the chemical reactivity. The chemical reactivity in the third one, first it decreases from sodium to magnesium to aluminum. It decreases like this. It decreases. Then after up to here it decreases. Then it increases up to here. Up to chlorine it increases, and there is no chemical reactivity in argon. Leave it. So you should say that as we move down from group 1 to 14, it decreases, and from group 14 to 17 it increases. This is the only trend. Got it? And since he is asking for particularly in third period, so in third period, then here you can write that, you say that sodium chemical reactivity is higher than magnesium and higher than aluminium and higher than silicon. This is the first trend. Next, silicon is lower than phosphorus, lower than sulfur, lower than chlorine. This is how the chemical trend is. So now, state the chemical reactivity down the group. What will happen down the group from group 1A to group 7A? That is a group 1 only. It's all in the group 1. So group 1 starts with hydrogen actually. So what is down the group, the chemical reactivity will decrease. Chemical reactivity of hydrogen is higher. You should say down the group, chemical reactivity will decrease. So in group 1A, hydrogen chemical reactivity is higher than what is below the hydrogen? It's a lithium, and it's higher than sodium. It is higher than potash. Like that you can start. Got it? And similarly, group 17A, what will happen? In group 17A also similar. Down the group it will decrease. Cr will decrease. So group 17A So group 17A is nothing
Sir, your CRS?
but chemical reactivity. He's asking for chemical reactivity here. Chemical reactivity here.
Okay.
Okay, right. I'm not able to mark this. Okay. Okay, now let's go to the group 17A is nothing but group 17. It is nothing but here also it starts with fluorine, and fluorine is greater than chlorine, and chlorine is greater than bromine, and bromine is greater than iodine, something like that. It goes on. Okay. Now an element X belongs to third period. Now there is an element which is a third period and 17th group. State number of valency electrons. Very easy. It is in group third. That means it has got 1, 2, 3. Three figures should be there. Very good. And now tell me what is the, it is in the 17th group. It is in the 17th group means it has got 7 at the end. So if it has got 7 at the end means it is 287, right? And what are the number of valence electrons? It is 7. Name of the element? Can you name the element 287? In the period 3? In the period 3 it is going to be chlorine. Okay. So let us go to the 9th. Name the family to which it belongs. Since it has got a 7, the family it belongs is halogen. Very good. Write the formula of the compound formed when X reacts with 2713Y. This is the, now you have to write a formula for this. How to write a formula? So this is an X. X has got a 287. X has got, this is the X which has got configuration. Configuration is 287. Okay. Now we say that this is reacting with 2713Y. 2713Y. Here 13 means what is the electronic configuration of 13? It is 2, 8, and tell me what it is going to be here? 3. So because this 13 is nothing but a atomic number. Atomic number is referred as a Z, right? So atomic number is nothing but number of electrons and number of protons. So it is going to be 283. So it is going to be here. So what it is going to do? It is going to, now we have to write a formula. What is the valency of this? Let us find out. Valency. So valence electrons are 7 here. Valence electrons are 3 here. But valency, this is valence electrons. So valency is different from valence electrons. So valency is, here it is 1. Here it is 3 means how much it is? It is going to be 3 only. So here it is going to, here it wants to gain plus 1. It wants to gain 1 electron. So that means minus 1 it is, sorry. It's going to be minus 1. It wants to lose 1 electron. So how do they react when they react? They react like this. This is X is minus 1 and Y is plus 3. That means this will go here and this will go here. So then it will become X3Y1. This can be written as X3Y. That means Y will combine with 3 numbers of X. Are you getting my point?
Yes, sir.
Y will, I mean this, if there is one Y, so it is going to combine with X, X and X, 3X. It is going to form a compound like this. So this is Y and this is combining with X here, X here, X here. And this is the bond that are creating here. So one Y is combining with the 3 atoms of X, because each atom of X wants to give 1 electron and Y wants to accept 3 electrons. So that's how they combine, and the compound is going to be X3Y. Hope you are clear, right? Please read the book and you will be able to be much more clear. Similarly, he says,
Yes.
write the formula of the compound formed when X reacts. So that we did it. Okay, now. So now, 10th one. The given table shows that the elements with the same number of electrons is in valence shell, right? So now tell me, the given table shows the elements with the same number of electrons in its valence shell. That is, in the outermost shell, same number of electrons are there. That means they belong to same group. If the same number of valence shell means they belong vertically, they belong to same group. Like ABC is one below the other. Okay, these things are, maybe which one is high we do not know. Now you state this, whether these elements belong to the same group period. Can you answer the first one? whether these elements belong to the same group or same period. Again, I am repeating my question. Please answer. 10th one. The given table shows the
So
elements with the
10th one,
yeah.
so
It
like
has got the
no,
same
it is
number of
not
valence.
same group.
It is not same group, but it is same period, is it?
Maybe sir, like I'm not
No,
sure.
it is other way. See what he says here. Here he says that it has got a same valence number. It has got same valence electrons. Same valence electrons. That means the end of the outermost orbit has got same number of electrons. So in a group, like say for example, group 1 you take. In the group 1, you have got hydrogen, you have got lithium, you have got sodium, you have got potash, something like this. So what is this? This has got 1 electron, 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 right? That means the valence electron here is same in the group. Across the group, valence electrons are same. Okay, so if you have got a groups, no, so you have got valence electrons same. In the group 1, valence electron is 1. In the
So
group 2,
like what
valence
they're
electrons.
given there was melting point, right?
No, it is not. It is not the melting point. It says that the given table shows the elements with same number of electrons in its valence shell. You read this.
No, so the 63.0.
Yeah, that is a melting point. That we will come later. First one, it is the same number of electrons in the valence shell. If it is the same number of electrons in the valence shell, then the first question can be answered without seeing the table. So answer the first question, whether these elements belong to same group or same period. They belong to,
So like I have like internet problem, not able to hear you
okay,
properly.
okay. See, you don't see the table. Don't see the table as of now. So only read. The given table shows the elements with the same number of electrons in its valence shell. What he says is, in these elements ABC, same number of electrons there in the outermost shell. Are you understanding? Samarth, are you getting my point? So
Yes, sir.
here they say that same number of electrons there in the outermost shell of all these elements. Now, whether they belong to same group or a same period, they belong to same group, because same number of valence shell is there, means it's the same group only. And you should remember, same group means same number of valence electrons. Valence electrons is nothing but the electrons in the outermost shell. And same period means in one period, across the period. Okay, same period means what? Same number of orbits or shells. It has got, say for example, if group 1 has got one orbit, period 1 has got one orbit, all the elements in the period 1 has got one orbit only. Similarly, period 2 has got two orbits. Period 3 elements have got three orbits. Period 4 elements have got four orbits. This is the basic.
Yes.
Okay, so please remember this. Okay, that's one. Now second one, arrange them in order of increasing metallic character. So metallic character will, what will happen? Metallic character is high in the top. Metallic character is high in the top. As you go down, metallic character will come down. This is a metallic character. Metallic character is nothing but their ability to lose electrons. So metallic character will, from high it will become low. If the metallic character is becoming low, the melting point also becomes low. Melting point is directly proportional to metallic character. Even that's also decreasing. So melting point is also decreasing. Now let us see these three. Which is the high melting point? High melting point is B. B is 180. I will write B, 180 degrees is the highest melting point. Next one is C97. C97. And next one is A63. So here it is B, C, like that. So the B has got a high metallic character, C is the next, and A is the lowest metallic character. So you are going to put at ACB. Here it is other way. It is decreasing means first I have to put increasing. No, metallic character is also increasing as you go down. It will decrease or increase. I also got confused. So let me see metallic character. So the melting point and boiling point of the metal will decrease going down the group. It will decrease. So what we wrote is right actually. It will decrease. So metallic character, melting point will decrease. So decrease means first you have to write the highest one and then it keeps on decreasing. So it has to be in the BCA only. Whatever we wrote is right because B is 180, C is, where was that? 97 and this is 63. So BCA is the order in which metallic points are decreasing. So metallic character is decreasing, metallic character is also decreasing. Okay, that's how it is. Okay, very good. Now let us go to the 11th one. Which one of the following has the largest atomic radius? Can you tell me which one has got the largest atomic radius?
Sir, in this, like, 1 second. Sir, I minus will have more than I.
No, I'm talking about 11th one. You are seeing 12th. So see
So
the
sorry,
11th
sir.
one.
Yes.
So sodium, potassium, magnesium, aluminium. Which one has got the largest atomic radius?
Sir, is it potassium?
Correct. How do you say it is potassium?
Sir, because sodium, magnesium, aluminum are same period, so they will be of same size. But potassium is in the fourth period, which is larger to that, so
Very
it
good.
will be more.
Very good. Very good. Very good. So
How do you write that in words?
yeah, you are right. You are absolutely right. So let us see here. If you try to put these things, sodium comes here and potassium comes here, right? And this is sodium, this is potassium. Then after that, you have got after the sodium, you have got
No, sir, like
magnesium.
I'm asking, how do you put it in words?
No, how do you, no, there is no word. You have to just say that which one of the following has the largest atomic radius. In this, you have to say that sodium is having the, no, not sodium, potassium is having the largest. Why? Because potassium is in period, which period it is in? It is in period 3 compared to all these things are in period 2. Sodium, magnesium, aluminium are in period 1. Therefore, potassium is having a highest. Okay.
Sir.
Period 3 is having it, magnesium is having the highest. That is the reason. What is the reason? Or you can see the mini periodic table which we draw. Here you see potassium is the 19th one. Here you see it is the largest. As you go down, this is the largest, and all other things are in other these things. No, they are in the period 2. This is 2. This is 3, and this is 4. Sorry, this is the fourth period. So potassium is having a 4 shells, 4 orbits. So it is the largest. That's it. No questions on that. And among the sodium, magnesium, and aluminum, which is the highest atomic size? Which atomic radius is highest?
Sir, in which one?
In the sodium, magnesium, and aluminum, which is having the highest potassium
Sir,
atomic radius?
I think 1 second, sir.
Sodium, magnesium, and aluminum.
So sodium, I think aluminium because no sodium.
Sodium, exactly. What will happen is across the
So
table,
because in sodium the there'll be only
electron,
one
one
electron
electron.
outside in the like in
Yeah,
the
so
valence.
it will pull that
So
one electron faster. Okay,
yeah.
the nuclear pull is higher, whereas here there are two electrons, so it is a smaller, and this is much more smaller. So like this, up to group 17, the radius will keep on reducing. Okay, that we have seen it. So that's how it is. So okay, now here 12th one, which one has the largest size?
Yeah, in this, like first it will be, we will see I minus is greater than I.
Very good. Now you have got
So
chlorine and
then
fluorine.
chlorine is chlorine is greater than, yeah, it is. Iodine is in which iodine is 53, I think.
Iodine, let us go here. So you have to see which
Iodine is
table it comes
53.
actually. Iodine and bromine. If you see in the fluorine, that is in the halogens, no? I don't know, here is halogens, fluorine, fluorine, iodine.
So,
First is the fluorine and then the chlorine and then bromine. So let us see here.
bro,
So that
I
is
think
same thing.
iodine, only iodine
Fluorine,
minus.
chlorine, bromine, and iodine. So iodine is in the period number 5 actually. Period
Iodine minus.
53. So iodine, in the iodine, it is going to be iodine minus. Okay. Iodine plus, iodine minus has got more number of electrons, right? So it is not that, only iodine, not iodine minus.
Because it will gain.
Yeah, it's iodine minus. It's iodine, only iodine. Even iodine minus is having less number of electrons. Iodine minus has got more number of electrons, sorry. So it is iodine is having more, and after that iodine minus, then after that what are all the things that were given here? Bromine and fluorine also were given, right? In the question. Then you have got bromine, bromine and chlorine. Then bromine, then chlorine. Chlorine is the smallest and bromine is higher than that. And iodine minus is supposed to be same, but what will happen here is the iodine is greater because it has got a here I minus is the first, sorry.
Sir, actually, I minus will come
I
first.
minus comes first and then the iodine
So
because this
this
has
will
got
be
more
a
number of
decreasing
electrons.
order.
Yeah, increasing order. It has got one electronic shell more actually. So it has got more.
Sir, what order is this? What
Sorry,
order is this?
it has lost.
What order?
This is in a decreasing order. So I'm decreasing order. So this is going to be in increasing order. Uh,
No,
yeah,
sir, you have
decreasing order. It is
placed
a
the
decreasing
elements
order.
only
That means
order.
this is the highest, this is the high, and this is the low. That is in the decreasing order. So hence I minus as the largest. This is the largest among all this. Okay, because this is the cation. Here he says that. Which one is the largest? So I minus has got the largest. Third one. Got it? Got it? Because it has gained one electron, so it is
Yes,
large.
sir, yes.
Yeah, very good. Now the metals in group 2 from top to bottom. What I will do is I will try to send all these questions to you. Please go through all the rest of the questions in case you are not able to get the answers. Do you all, if both of you have the book, or if you don't have the book, I will send this page. So from
I have sir book.
you have the book. Okay. From 10th 10, up to 12th, we have done it. From 13th to 21st, please try everything. And in case you are not getting the answers, I will send you the answer. Please send me on WhatsApp which answer you are not got it. Then I will send you the answer for that. Okay. I will send you the answer for that. But
Okay,
please
sir.
try to do that on yourself. This is a homework for you. Up to 21, do it. In case
Okay,
you
sir.
are not understanding the answer, please ask me. And next, we are going to cover the next in text, that is going to be the last one, and then we are going to have the final exercise which you need to do it on yourself, all this exercise. Then again we are going to have a test on this. Please remember, I'm going to give one more test on this chapter. And Yashasni, did you get the your timetable for the unit 1?
Oh, sorry, sir, I had to send you that, right?
Yeah,
Sorry, I
please send
forgot.
me along with the portions.
Yes,
Because I
I'll
want to know
send
the
that.
dates as well as portions. Anyway, you have told me in, I think, chemistry you said one chapter, in physics also one chapter, in
Oh no, chemistry first two chapters.
first to two, is it? Okay, second chapter also we have to do then in that case before that.
Yeah.
Okay, okay, right then.
Yes.
Okay, with this we will end. So I'm going to send you all the exercise questions. Anyway, you have got, please attempt all the exercise questions. Read this chapter. Let us go to the second chapter, if possible, in the next. If you are all
Yes.
okay, so I will start the second chapter in the next class. And physics is only one chapter, you said, right?
Yes, sir. Physics only
Then
one
okay, you
chapter.
have done that chapter. It's okay. For the chemistry second chapter, we will do it, and then we'll go to the physics later.
So maths only first two chapters. That is also
Only
we have
first.
done.
Okay, we are doing the second chapter now. That we will be able to conclude it.
Yeah.
Okay,
Fine.
right then. So with this, I will end the class.
Okay, sir. Thank you.
Please go through, and this is all homework for you. Please go through
Yes.
this.
Okay, sir. Thank
Okay,
you.
okay. Please read. This is a 10th class. You got to put a lot of efforts. Hope you will all put that. Okay. Thank you.
Bye.